Building air leakage. The references for this particular procedure are reference appendices found in section RA 3.8, and again you can find the same documents for download on the LMS and also from the California Energy Commission website at that link shown on the screen. So the building air leakage. The purpose of this test procedure is to measure the air leakage rate through a building enclosure measured in cubic feet per minute at a negative 50 pascal pressure difference. So what that means is the fact that we're going to be depressurizing the house to negative 50 pascals for the purpose of this test with a blower door. Now please don't confuse yourself with the blower door used for this particular test and the one used for the duct leakage to outside. Now it's the same equipment. However, when you're doing duct leakage to outside, as explained previously, you're pressurizing the house to 25 pascals. When you're talking about the building air leakage, also known as infiltration testing, also known as the blower door test, you will be depressurizing the house to negative 50 pascals. So different test criteria. Keep that in mind. So the overall training goal here is to familiarize yourself with the building air leakage testing, equipment, protocols, and forms. Again, we're just going to give you an overview of the test, what it looks like, what it feels like, what it's designed to do, and then you're going to be doing it hands-on with the actual equipment once you actually get to your field training. And these are the sections that we're going to be covering today.
The pressure gauges shall measure pressure difference with a maximum error of 1% of reading or 0.25 pascals, whichever is greater. The fans used for building air leakage testing shall be capable of moving air into or out of the building to achieve one or more target pressure differences between the house and the exterior. The thermometer must be able to measure air temperature with an accuracy of plus or minus 1 degree Celsius or 2 degrees Fahrenheit.
Before we actually conduct the test, we have to prepare the house for testing. So there's different things that we have to prep and make sure that they're in the correct setting before we can actually run the blower door. So certain components of a house you will have to prepare for building for air leakage testing. And those are doors and windows, attached garages, crawl spaces, attics, interior doors, vents and dampers, whole house fans, supply registers and return grills, window vents and through-the-wall vents, and combustion appliances. So doors and windows that separate conditioned space from unconditioned space shall be closed and latched. So any window or door that separates the exterior of the house to the interior of the house has to be closed and latched. In attached garages, if the blower door is installed between the house and the garage, meaning that you're installing the blower door on the door that separates the house from the inside of the garage, then the garage shall be open to the outside by opening at least one exterior garage door. So if you're installing the blower door at the separating door between the house and the garage, either the main garage door or a side garage door has to be open within the actual garage for the test to take place. As far as crawl spaces are concerned, if a crawl space is inside the conditioned space boundary, interior access doors and hatches between the house and the crawl space shall be opened, and exterior crawl space access door, vents, and hatches shall be closed. So basically, if it's a living crawl space or the crawl space is within the conditioned boundary of the house, you have to take it into account as part of the house. So the hatch to the crawl space will be open, and then any exterior opening from the crawl space to the outside of the house has to be closed. If a crawl space is outside the conditioned space boundary, interior access doors and hatches shall be closed. For compliance testing purposes, crawl space vents shall be open. So again, if the crawl space now is an outside crawl space, meaning that it's outside of the living space, then the hatch to the crawl space has to be closed because it would be the equivalent of an exterior door. For attics, it's the same principle as the crawl space. So if an attic is inside the conditioned space boundary, interior access doors and hatches between the house and the conditioned attic shall be opened, and attic exterior access doors and windows shall be closed. So again, if the attic is part of the conditioned space of the house, the door to the attic will be left open, and any doors or windows that go from the attic to the outside of the living space have to be closed, just like you would count in the rest of the house. If an attic is outside the conditioned space boundary, interior access doors and hatches shall be closed, and exterior access doors, dampers, or vents shall be left in their found position, and their position during testing shall be recorded on the test report. Interior doors shall be open within the conditioned space boundary. Any interior door has to be open. Chimney dampers and combustion air inlets on solid fuel appliances. The dampers shall be closed. Please take precautions to prevent ashes or soot from entering the house during testing. Although general intent of this standard is to test the building in its normal operating condition, it may be necessary to temporarily seal openings to avoid drawing soot or ashes into the house. So you will be depressurizing the house, meaning that you'll be sucking air outside of the house. When the blower door starts and you depressurize the house, the blower door is going to be sucking air from whatever crevice it finds within the house itself. If there are ashes or dirt or anything in the chimneys, in the appliances, or wherever it is that they may be, those ashes, that dirt, those contaminants will be pulled into the house and through the house, depositing on the carpet, making a mess, generally speaking, just causing problems. So that's why they allow you to do this if need be. Any temporary sealing, keep in mind though, shall be noted in the test report. Combustion appliance flue gas vents shall be left in their normal appliance off condition. Any fan or appliance capable of inducing airflow across the building enclosure shall be turned off. This includes, but is not limited to, clothes dryers, attic fans, kitchen and bathroom exhaust fans, outdoor air ventilation fans, air handlers, and crawl space and attic ventilation fans. Continuously operating ventilation systems shall be turned off and the air openings sealed, preferably at the exterior terminations. So keep in mind, that's continuously operating ventilation systems, so not the intermittent fans that you see in a bathroom or in a laundry room necessarily. That exception to be turned off and sealed, keep in mind that's only for continuously operating ventilation systems. It's very specific. For motorized dampers which connect the conditioned space to the exterior, the damper shall be placed in its closed position and shall not be further sealed. So you're going to close it and you're not going to seal it any further. Non-motorized dampers which connect the conditioned space to the exterior or unconditioned spaces, those type of dampers shall be left as found. If the damper will be forced open or closed by the induced test pressure, the fact shall be reported in the test report. Closed dryer exhaust openings should not be sealed off even if there is no dryer attached, but this fact should be noted in the test report. And the picture that you see on the right is obviously an example of a dryer vent without a dryer connected to it. Undampened, fixed dampers, or intentional openings between conditioned space and the exterior or unconditioned spaces shall be left open or fixed position. However, temporary blocking shall be removed. Now, along with the same subject, keep in mind the exception again. Undampened supply air or exhaust air openings of continuously operating mechanical ventilation systems shall be sealed, preferably sealed at the exterior of the enclosure, and ventilation fans shall be turned off. So we mentioned this earlier when we were talking about fans already, but keep in mind, continuously operating mechanical ventilation systems shall be sealed and the fans will be turned off. So this exception only applies to continuously operating mechanical ventilation systems, nothing else. Whole building fan louver shutters shall be closed, and if there is a seasonal cover, it shall be installed. Now for evap coolers, the opening to the exterior shall be placed in its off condition, and if there is a seasonal cover as well, it shall be installed. Operable window trickle vents and through the wall vents shall be closed and or sealed. These you can actually seal if need be. Supply registers and turn grills shall be left open and uncovered. Plumbing drains with P-traps shall be sealed or filled with water if empty. The reason this is important is because if you do the blower door and this is not the case, you're going to be sucking sewer gases through those pipes. So it's important that the P-trap is filled or sealed so that you're not going to be bringing contaminants or odors within the house. Combustion appliances shall remain off during the test. If during the test induced pressures affect operable dampers, seasonal covers, etc., reestablish the setup and consider reverse direction of the fan flow. It's very important that combustion appliances stay off or on pilot during this test because of the fact that you will be depressurizing the house. If the combustion appliances are running, there is a chance that you might create backdraft, which is obviously at a hazardous condition. So make sure 100% that the combustion appliances are either off or on pilot. And now we're going to be talking about the specific procedures to conduct the blower door. Warning, use caution when deciding how and whether to test homes with potential airborne contaminants, for example, fireplace ash, mold, or asbestos, and refer to local, state, and national protocol standards for methods to deal with these and other contaminants. Always do a walk around of the house and a quick assessment of the house to make sure that there are no potential dangers that you're going to be bringing into the house or be creating for the homeowner before starting the blower door. As far as the setup is concerned, unless otherwise stated, we will cover depressurization testing. Depressurization testing is the primary method to test for the blower door, and those are the standards that we use in California according to the reference appendices. So again, unless otherwise stated, we will cover depressurization testing. You'll be sucking air out of the house. You want to install the blower door system in an exterior doorway or window that has an unrestricted access to the building and no obstructions to airflow within 5 feet of the fan inlet and 2 feet of the fan outlet. Avoid installing the system in a doorway or window exposed to the wind. Obviously, wind pressures and wind movement is going to affect this test. And as a matter of fact, if you're trying to conduct this test on very windy days, it might not be a very accurate test. It is permissible to use a doorway or window between the conditioned space and unconditioned space as long as the unconditioned space is an unrestricted air pathway to the outdoors. For example, an attached garage or porch can be used as the unconditioned space. In this case, be sure to open all exterior windows and doors of the unconditioned space to the outdoors. So like we talked about earlier for the garage door, if you are using the blower door on the door between the house and the garage, it's okay to do that as long as you actually open the exterior doors to the garage, whether that's the main garage door or a side garage door. So the first step is building the frame. You'll be doing this hands-on during the field training. The blower door is very easy to assemble. You're basically just snapping the corners together and putting it in one piece. You're going to fit that frame to the opening. The blower door itself has a series of cam and locks that basically allows you to adjust the height and width of it, and you're going to fit it to whatever door or window you're putting it on. And then you're going to attach the tarp to the frame with a series of Velcro straps that are built into the frame itself and the tarp. You then are going to install the frame to the opening. And please look on the right hand side, you'll see the blower door frame attached to the door itself, right? And then you'll see the green line. So the green line is the outside pressure tubing and should be placed away from the fan exhaust. So you're going to be taking a blower door reading of the pressure of the inside the house with reference to the outside. So that hose that you'll be sticking through the blower door and out of the house, that's taking the outside of the house reading. It's really important that you put that hose away from the fan itself, because if you leave that hose in front of the fan, it's going to skew the numbers because obviously it's going to be in the direct contact of the fan flow. So just take that hose, put it out, and throw it off to the side so that it's not affected by the actual fan flow of the fan. You then are going to put in the fan itself into the opening of the frame and the tarp, and you're going to be securing that fan to the frame so that once you turn it on, it doesn't move. And then you're going to install the pressure gauges, fans, and tubing connections according to the equipment manufacturer's instructions. And again, these are two of the manometers that we talked about earlier. There's two more that are not pictured here, but nonetheless, they're still available. We'll be going through the actual setup procedures for the tubing and the manometer hands-on in detail once you actually get through your field training. This is just to give you the idea of what the test looks like. And that's the final product. So you have the Minneapolis blower door on the left and the Retrotec blower door on the right, installed on what it looks like to be the front door of two different houses. You might get in a situation where the blower door is not big enough for the opening. You might have an 8-foot door, and maybe the blower door doesn't quite reach all the way up for whatever reason. You can tape the excess shut as long as it's sealed, as long as it's completely sealed from the outside. So as long as you tape it up and there is no infiltration points within your taping and sealing, you're fine as well.
Now, before we get started with the actual blower door test, we are going to need to take a couple of recordings of different values of a temperature and elevation. So we're going to need to record both the indoor and outdoor temperatures in degrees Fahrenheit, and you need to do it to an accuracy of 5 degrees. So what does that mean? Let's say if it's 83 degrees, you're going to simply round up to 85. If it was 82, you're going to round down to 80. So you get to the closest 0 or 5, whatever's closest. Then you're going to need to record the elevation of the building site, and that's going to need to be within an accuracy of 500 feet. So 1,000, 1,500, 2,000. Both of these values are going to be used for accuracy adjustments, and those will be taken care of on the actual form itself. So once you get your test results, you can enter them on the form itself, the ENV20. Plug these numbers in, and it's going to make those calculations to let you know if your actual blower door reading is within spec when taking into account these accuracy adjustments. For the blower door test itself, we're going to be doing what's called a single point test. This means that we're going to be measuring the air leakage one time at a single pressure difference, and this will be described in ResNet 380 3.4.1. And we're going to go through all those steps here.
A single point test may only be performed if the maximum induced building pressure is at least -15 pascals and greater than 4 times the baseline pressure. So you're going to be hearing the term induced building pressure quite often during this presentation. The induced building pressure is the pressure of the building while the blower door is running. So basically, when we talked about the fact that we're going to be depressurizing the house to -50, -50 is our goal for induced building pressure. We want to get it all the way to -50. The reality of it is the fact that a home might be so leaky that you cannot depressurize it to that much because there are so many leaks in the house that you cannot suck that much air outside of it. That means that as long as you can get the house to reach at least -15, you're good to go. If the house is so leaky that you can even get it to go to -15, it's going to be a no-go. You're not going to be able to conduct your test. And on the right-hand side, you're seeing an example of the Minneapolis manometer screen and the Retrotec DM2 manometer screen. And that's just to give you an example where you will see that particular number. So the -15, that's the threshold. You got to be at least -15 or more negative than that.
So if you do get into that situation where you are unable to produce a pressure differential greater than -15 pascals, which greater than -15 means that you're getting closer to that -50 pascal target that we want to hit. First thing you want to do is go back and recheck that the house is set up correctly and determine if there's any basic repairs that are needed prior to further testing. Maybe there's a broken window that you missed. There's not weather stripping on the doors. You know, there could be a variety of things that are allowing air to infiltrate into the building through sources that would normally be closed during a normal test. Now, if the setup looks good, you don't find any issues with it, the house may just be large enough that your single fan can't achieve that -15 pressure. So you can use multiple fans. They'll be used at the same time to try and produce that pressure differential that we need. So if you're going to use those multiple fans, simply follow the manufacturer's instructions for those measurement procedures.
So on the manometer, first you're going to choose and record a time averaging period of at least 10 seconds to be used for measuring pressures. So you'll do this once you get to your actual field test, but basically the manometers have settings to basically time their readings. So you can set the reading time to be taking a reading every 5 seconds, 10 seconds, 30 seconds, 1 second, or even live readings where it's taking it non-stop. So the time average, you want to set it to at least 10 seconds, which is a setting available on both manometers and from both manufacturers. With the blower door fan sealed and off, you want to measure and record 5 independent average baseline building pressure readings with respect to outside to a resolution of 0.1. So once you get to your field test, we're going to refer to this as taking the baseline. When you hear we're going to be taking the baseline before the blower door starts, this is what we're talking about. So the blower door will be off, it will be sealed, it'll be completely connected to the manometer, and all you're doing is looking at your manometer and taking those 5 independent readings at 10-second intervals, kind of to get a baseline for the house in natural conditions.
So you'll conduct and accept that baseline measurement with a digital gauge for a period of at least 10 seconds. Generally, we recommend a little bit longer than that, but that is the minimum. If you desire greater accuracy, a longer time averaging period may be used. I prefer doing a 30-second reading. Just gives you a smoother and more a better average value than at 10 seconds. Now, most digital gauges will automatically adjust the readings once you accept the baseline measurement. And when you get into starting to fill out your form, there's 2 options. There's a single point test with a manual meter, and there's a single point test with an automatic meter. Most of the meters that you're going to have nowadays are going to be automatic meters, and they're going to do just that. Once you take your readings, you're going to enter them into the gauge. Each of them has a little bit different way to set that, and it will then adjust your gauge based on this baseline reading.
Once you did all that, you're going to unseal the blower door fan. You're going to turn on and adjust the fan to create an induced building pressure of approximately -50 pascals. So -50 is our target. If a -50 pascal induced building pressure cannot be achieved because the blower door fan does not have sufficient flow capacity, then achieve the highest induced building pressure possible with the equipment available. So if you cannot get to -50, do the best that you can. You also might have to change rings around and try different combinations to see what works and what doesn't. Even after you do all that, if you still cannot achieve -50, just record the value that you can get.
So after you get the fan all set up, it's running, you're as close to that -50 pascal target as you can get, or at -50, you're going to record the following information. So you're going to record that induced building pressure, which hopefully you can get it to that -50 pascals. If not, then record what you were able to get to, remembering that you need to be at least -15 or better, or more negative, in order for it to be a valid test. You're then going to record the nominal CFM50. So on the gauge itself, it's not only going to read the induced building pressure, but it's also going to read the airflow through the fan in CFM50. So you're going to write down that value. You're going to record the fan configuration. So that means each of those fans has a set of different, we call them rings or openings. Each one's a little bit different, but they will be either numbered or lettered. And you're going to need to record what ring or set of rings were installed on the fan, or if it was completely open with no rings, then it would just be open, but identify what you used. Record the fan and manometer model numbers as well as the serial numbers. All of this information will be required to be input on the form itself.
And this is an example of on a Minneapolis DG gauge where you would get that information. So you would have the fan model on the left-hand side, the induced building pressure, -50, like I said, the fan configuration, those are basically the rings that you're using and the setting of the fan, and then the airflow reading, which is for the purpose of the Minneapolis, is going to be on the right-hand side of the screen, and that's going to be in CFM. So remember, pressure is always measured in pascals, airflow is always measured in CFMs. And this is the example for the RetroTech. It's the exact same items, just in different locations because the screen looks different. So you have the fan configuration at the bottom left, the fan model on the bottom right, and then you have the induced building pressure at the top and the nominal airflow right underneath. Again, pressure in pascals, flow in CFMs. And you'll see right there on the screen that says pressure and flow as well. So it's very hard to get confused about the two.
Now, once you've collected all of the required data, you will need to compare to the values modeled on the CF1R. So if you look at the PDF of the CF1R that's generated, you'll want to scroll down until you find the building envelope HERS verification section, and then you look over there in column number 4, it lists the target CFM 50. So you would need to be equal to or less than this value. Your test results will need to be equal to or less than the value that's displayed here, taking into account any adjustments that need to be made for elevation or temperature. So the easiest way to do this is to take your value, jump into the CF3R ENV20 or CF2R if you're doing this test for the contractor, which oftentimes happens. Enter in all of your data there. That form will automatically perform those adjustments and calculations and give you your final CFM50, your adjusted CFM50, and that's the value that will be compared. This value, you can see in here, the 945 CFM50, that value will also be present on both the CF2R and CF3R versions of the ENV20 form. So you can also go straight there to get that value, plug in your results, and it will make those adjustments and calculations to let you know whether or not it is passing or failing.
Now we're going to be covering or talking about the forms associated with these tests. Keep in mind that the forms, again, are downloadable in paper copy just for practice purposes from the LMS and also from the California Energy Commission website. The CF3R EMV20 Alpha, it's used for the building envelope air leakage single point test with a manual meter. The CF3R EMV20 Bravo is used also for the air leakage test single point with an automatic meter. Again, if you have any questions, always feel free to get a hold of us through the messaging system, shoot us an email, or give us a call.